In the last episode, we covered the basic concepts and forwarding principles of VXLAN. Today, we'll continue by looking at some VXLAN usage scenarios. On a typical spine-leaf data center network, an enterprise has multiple departments, with multiple VMs in each. VMs of the same department reside on the same network segments, while VMs of different departments reside on different network segments. In this case, how can we deploy a VXLAN network to implement communication between intra-department VMs, between inter-department VMs, and between VMs and the Internet? First, deploy Layer 2 VXLAN gateways. Specify Leaf 1 and Leaf 2 as VXLAN VTEPs. Set up a VXLAN tunnel between the two leaves, and deploy a Layer 2 VXLAN gateway on each leaf. VMs in the same department can then communicate with each other. Second, deploy Layer 3 VXLAN gateways, which, depending on the location at which the gateways reside, can be centralized or distributed. In centralized mode, both leaves and spines serve as VXLAN VTEPs. Leaves are used for Layer 2 traffic access, and spines function as Layer 3 gateways. In this mode, set up a VXLAN tunnel between Leaf 1 and Spine 1, and between Leaf 2 and Spine 2, and deploy a Layer 3 VXLAN gateway on Spine 1 and Spine 2. VMs in different departments can then communicate with each other, and VMs can access the Internet. In distributed mode, only leaves serve as VXLAN VTEPs. Each leaf functions as both a Layer 2 gateway and Layer 3 gateway. In this mode, deploy a Layer 3 gateway on a single leaf. The VMs in different departments attached to the leaf can then communicate with each other at Layer 3. Deploy a Layer 3 gateway on both leaves. The two Layer 3 VXLAN gateways dynamically establish a VXLAN tunnel through MP BGP and advertise their host routes to other BGP peers through BGP Remote Next Hop attributes. The VMs in different departments attached to different leaves can then communicate with each other. Centralized and distributed Layer 3 VXLAN gateways differ in the following aspects. You can select one based on your networking requirements. On the preceding VXLAN network, single homing access is used between VMs and leaves, and between leaves and spines. This access mode is unable to meet users' high reliability requirements on the VXLAN network. In this situation, iStack and MLAG dual homing access can be used to improve reliability of the access layer. All active gateways can be used to improve reliability of the core layer. Use iStack to improve reliability of the access layer. iStack can aggregate numerous switches at the access layer into one virtual switch. All configurations are performed on the virtualized switch, simplifying O&M at the access layer. Stack members can implement both redundancy and load balancing among inter-device ETH trunk links. While iStack simplifies deployment through centralized configuration, stack members cannot be independently upgraded, and services will be interrupted significantly during the iStack upgrade. To overcome this limitation, MLAG dual homing access can be deployed. The two devices forming an MLAG can be upgraded independently, ensuring uninterrupted forwarding of services. However, MLAG configurations are a little more complex than iStack configurations. Use all active gateways to improve reliability of the core layer. Core layer devices are geographically scattered, meaning traditional device level backup is not up to the challenge. Protocol level backup can address this issue. In all active gateway networking, multiple spines have the same IP address and MAC address configured in order to appear as one virtual VXLAN VTEP. A Layer 3 gateway is then configured on each spine, so that each one of them is able to provide gateway services by forwarding the received traffic to a next hop device. These spines can also achieve load balancing for traffic forwarding. When the number of network devices is constantly expanding on an increasingly complicated VXLAN network, configure a controller on the VXLAN to facilitate network node control and deployment. A controller acts as a unified network control platform, controlling VXLAN tunnel establishment among devices through netconf, as well as packet forwarding over the tunnels through OpenFlow. That's all we're going to cover on VXLAN usage scenarios. For more VXLAN information, please visit e.huawei.com.